In this video, let's look at how to perform full two-port calibration on a Copper Mountain Technologies two-port VNA using PicoTest calibration substrate and also using the two-port probe, that's the P2102A. So the measurement that we will be doing in the end is on the PicoTest evaluation board, and we'll be checking the measurements at the output. All right, so before we begin with the calibration, we will first make sure that we have the right definitions. So for that, we'll go to calibration, calkit. We either select and define a calkit. So we'll go to open, and so we'll consider everything to be ideal. So we'll just enter it as 0 all the way, including the delay. And also the same thing for short. And for load, we'll assume an ideal 50 ohm load. And we'll use unknown through, so that's why we have selected an unknown through here. But we also have through as another option. So what we'll be performing the full two-port calibration, that's the SOLR calibration. So hence we have the unknown through defined here. So now that we have it defined properly, we'll go to calibrate, full two-port calibration. We will select the probe along with the tip. So we'll use the 0603, but there are other tips to choose from as well. So we'll be using the same tip to perform measurements, so that's why we're using this for calibration. And now here is the substrate. So first, what we'll do is we'll do an open. So we're not connecting to the cal substrate at this time, so we're just doing the open connection. So you can see S11 and S22 phase is close to 0 there at low frequencies. So next, what we'll do is the isolation. So this is to perform isolation as well as the short calibration. So now looking at this at the VNA screen, we have S11 and S22 close to 180 degrees, so indicating a short connection. So we'll click on short, port 1, port 2, as well as we'll do the isolation. And next we will do the load. So for that, we will look at the S11 and S22 log mag response. You can see pretty decent return loss there on S11 and S22. So we'll click on load on port 1, followed by load on port 2. And the last step is to perform the through cal. All right, so now we have S21 and S12 close to 0, indicating a good through connection. And then we'll do unknown through. All right, and then we click on apply. All right, so now the calibration has been performed, and then the calibration plane has been moved to the end of the probe tips here. So now what we will do is we will measure this board. So we'll power it up, and we will zoom into the response here. So we'll do the settings for it. So I'll turn on Z21 and maybe linear to begin with to see the impedance. And all right, so now we have it set. All right, so we'll use the pro tip and then connect to the output of this regulator. So you can see the response is kind of hairy. So we can reduce the IF bandwidth to reduce the trace noise. All right, so I've reduced it to maybe to 300 Hertz. And now we can see a pretty decent response there. We can also look at the measurements with and without calibration. So So this is with correction on, so we'll put this to memory to just compare, and then we'll do correction off. You can see there is some small difference there. We can also zoom in and see how the measurements would look like in either the log scale or the linear scale. I can add a marker and see that there is some small difference here. At the peak here, as well as at low frequencies, as well as at high frequencies. So yes, so calibration does make a difference, and these are the right steps to achieve good calibration. If you have further questions, please send us an email, support@coppermountaintech.com. Thank you.